All right, how we doing? Algebra 2. Hey, listen, guys, we are jumping into chapter 3 now, but as you can see on the page there, we are skipping section 1. All right, so make sure that you are very aware of that. We are skipping section 1, immediately moving into section 2, which is titled solving solving linear systems. Okay, so let's jump into our notes right there. So we have two main methods that we're going to be using in this section, substitution and elimination. And you guys did learn this back in Algebra 1, so that was a little while ago, but it's basically the exact same thing, just kind of revived up. And of course, there may be, some tricks here and there that would help you along the way, especially in Algebra 2. But pay close attention, because as you also see in the note, both methods will work for every problem. It's just that the way the problem is given, there's usually one of those methods that works better. Okay, so depending on how the problem is presented to you, substitution might work best, or if it looks a little bit different, elimination might work best. All right, so that's pretty much what that note right there is saying. So if you were to have both of the variables on the same side, there's a good chance that the elimination method will work best. The times when substitution works best is when either one of the equations already has a variable solved for, so like it says y equals and then everything, or x equals and then there's everything, or technically if you have x and y together, but one of those variables just has the coefficient of 1, then you could actually set it up to still use the substitution method. But you'll see me do that for these example problems, okay? Now, one of the last notes you're going to see is they may ask you to classify a system to determine the number of solutions. And when we say number of solutions, we mean like, is there only one solution? Is there infinite solutions? Or is there no solution, okay? And so the first thing you have to do is solve each equation for y. So they have to say y equals, and then there's everything else. The reason why is you want it into slope-intercept format, and then we can move on to either step 2, 3, or 4, depending on how those equations now look when they're solved for y. So if they have different slopes, immediately there's one solution, and then you would say it's consistent independent. If they have the exact same slope, then you have to do one more thing, and maybe it's identical equations. Okay, now both sides are completely equal to each other. So in that case, if you have two equations that are identical, then you have infinite solutions, and then you would also say that it's consistent dependent. All right, but if you have the same slope but different y-intercepts, so that's that plus b value, then we have a no solution situation. And the reason you would have no solution is because you would have parallel lines that would never cross. And if they never cross, there won't be a solution, okay? The one time you'll have infinite solutions is if you literally have one line and another is the same. So every single point, they will be always identical. All right, let's take a look, do some example problems here. All right, number 1. We're given y equals 2x minus 1, then 3x plus 2y equals 26. This is set up where one equation already has y equals, so we're going to use the substitution method. Okay, so just put that off to the side. Substitution method is the best one here. Now, how do you use the substitution method? Well, basically, we're going to take this first equation, put it in parentheses, and we will literally substitute it in to the other equation, because it is saying, hey, this is what y is. Okay, so if I take y out of the other equation and replace it with 2x minus 1, that's the same thing. All right, and why we want to do that is because then we will have the same variable. All right, so let's rewrite that. 3x plus 2, and then substitute the 2x minus 1 in. And now you'll notice the y is gone. All we have is x. We could solve for x if that's the only variable we have here. All right, so use the distributive property. 3x plus 4x minus 2 equals 26. 3x and 4x make 7x minus 2 equals 26. We're going to add 2 on both sides. So now we're looking at 7x equals 28. Then final step here, divide both sides by 7. Isolating x, x equals 4. All right, now we are not done. All we solved for was x, but to solve a system, you have to solve for x and y. So now you take this x value and plug it right there because that equation is set up for y. So now if I put that x value of 4 in, the answer that comes out is what y equals. So now we have y equals 2 times 4 minus 1. In other words, 8 minus 1. So y equals 7. All right. So that's what we're looking at here for substitution. Okay. Let's go ahead and take a look at the second example problem. And let's see if there's a way that we can get rid of this negative sign, okay? Because we don't want that negative sign to be with y, but we do like the fact that y is by itself, okay? So if we were to completely rearrange this equation, that would work. Or essentially, if we were to take this whole thing and multiply it by a -1, every single sign would change. But most importantly, we care about y changing to a positive. So now what we would have is y equals -2x plus 2. So you notice how every single sign is now just the opposite of what was given. Okay? Now this right here is what y equals. So we're going to substitute that in right there where we see y. So 5x plus 6 parentheses -2x plus 2 equals -9. All right, distribute 5x minus 12x plus 12 equals -9. Now, 5 minus 12, that's going to give us a negative, let's see, and -7x plus 12 equals -9. Now we're going to subtract 12 from both sides. All right, cross those out, cross those out. Now we have a -9, but minus 12. That's going to create a bigger negative. So now you're looking at -7x equaling a -21. Divide both sides by 7. That's a -21. It's a -7. It's going to be a +3. Okay. Now take that value and plug it in right there for x because that equation is now perfectly set up for y. So y equals a -2 times a +3 plus 2. So that's going to be -6 plus 2. Y equals a -4. All right. Always remember, you must have an x equals and a y equals. You can't just get x and be done. Can't just get y and be done. You got to have both parts. All right. Let's move into example 3. Oh boy. All right, we got to pick up the pace here. We got a few examples more to go. All right, so in this one, we're going to use the elimination method. Here's why. For starters, x and y are on the same side, but also take a look at those coefficients. None of those coefficients are 1. So in this case, we are going to eliminate one of these variables. And which variable is easiest? The y. The y is easiest because notice they have the same coefficient. They're just opposite signs. When they are opposite signs, you will use addition for the whole problem. So I'm going to put that addition sign in parentheses. And that means we will be going straight up and down, kind of old school method using arithmetic here. And we're going to go 4 minus 12. All right. And these guys will cross each other out. That's excellent. So we have a negative 8x. The y's are now gone. And then a negative 25 plus 19, giving us a negative 6. Divide both sides by negative 8. And now we have x equals, both are negatives, so that's going to reduce that down to be a positive, but it's still a fraction, 3/4. Okay. Now in this case, it's completely up to you guys what equation you want to plug this into. My recommendation is I would take this and plug it in to that x right there. The only reason is because we actually have a little bit more positive numbers to deal with, where the bottom one has a negative, minus, okay? So we're going to substitute x in as 3/4. So that's 4 parentheses 3/4 plus 7y equals a negative 25. Okay. 4 times 3/4 is going to be 12 over 4, which perfectly reduces down to 3 plus 7y equals a negative 25. All right. And just to save us a little bit of time, you guys know how to solve these. All right. So we're just going to jump right down. You would simplify, isolate the y value. And in this case, y is going to equal a negative 4. All right. Okay. Next one here. Notice how it is set up. Okay. For starters, we got one quick mistake that I just noticed. That should be a y. Okay. Now, for this situation here, notice how none of them perfectly match, all right? I don't have a 3y and another 3y, or a 5x and another 5x. So what we're going to have to do here is we're going to have to create a perfect coefficient. So what we could do is we could take this entire equation and multiply it by 5, and this entire equation and multiply it by 3, okay? And if we do that, what we're going to see is our y coefficients will both perfectly match up because they will both be 15. All right, so we're going to have a 25x minus 15y equals a, let's see, 210. And then on this side, we're going to have a 24x plus 15y equals, let's see, 28 times 3 is 84. All right. Now we simply go through the identical steps we did in this problem right here, where we notice we have a positive and a negative 15. So because those signs are opposite, we will be using addition throughout this entire problem. Okay, that addition allows us to cross these guys out, a negative 15, a positive 15, they eliminate each other. Then you have a 25 plus a 24 equaling 49x, and then 210 plus 84 equaling 294. Divide that by 49, and it works out perfectly. X equals 6. All right. Now, here's where you can use the original equations. All right. You do not have to use the 25x, 15y, 210 equation. You could simply take this value right here and plug it in right there back in the original equation. So that would be 8 parentheses 6 plus 5y equals 28. All right, go through the necessary steps to solve that, and you would get y equals -4. All right, don't forget those steps. You do 8 times 6, then subtract, then divide by 5. Everything works out perfectly there. All right, let's do our very last one here. So we need to classify the system, meaning we need to solve for y first, then determine what are we looking at here. Do we have same slope, different slope? What's left? All right, so the first thing we would do is you take that guy, move it over here. That creates y equals -7x minus 4. So that equation is done. Take this guy, move it over here, and then everything's going to be divided by 8 because we got to isolate y. So now we're going to get y equals, let's see, that 56 is going to become a negative. Okay, so we're going to get a -7x, and then that 32 is going to be divided by 8 also, and that's going to be a -4. Now, what do you notice here? These equations are the exact same. So we would have a infinite solution on this one right here because the equations are completely identical. All right, last little piece here. Okay, take the 2x, move it over. Y equals -2x minus 6. And then take that 6x, move it over here, divide everything by 3. And if you move the 6x over, it's going to be a negative, divide by 3. Let's see, you're then going to have a -2x, and divide that, that's going to be -4. So notice we have same slopes, but different y-intercepts. So this is going to be a no solution. All right, sorry guys for the long video, but that covers everything you're going to need for section 2. All right, we'll see you later.